Chapter 7.2, Hypothesis Testing using p-values. And the problem says in auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time, that means 4 new tires and fuel, is less than 13 seconds. A random selection of 32 pit stop times has a sample mean of 12.9 seconds and a standard deviation of 0.19 seconds. Is there enough evidence to support the claim at alpha equal to 0.01? And it says to use a p-score. Alright, here's our hypothesis. The null hypothesis is that mu is greater than or equal to 13, so the mean is greater than or equal to 13, versus the alternative hypothesis, which would be mu is less than 13. This is a left tail test because you can tell according to the sign. The level of significance is 0.01. That's what alpha is, and that's what you're going to use to determine, once you know the p-value, whether you're going to reject the null hypothesis or you're going to accept it, or fail to reject it. So use the standardized test statistic. So here's what you're going to do. You're going to go to stat, over to test, and down to number 1, z-test. And you're using sample statistics, so you're going to go to stats for the input. Okay, so that's going to be your answer. So let's go to the calculator now and let's actually do this problem. So we're going to go to stat, over to test, and we want the first one, which is z-test. And we're using statistics because we're using the mean and the standard deviation. So we're going to go over to stats, and the numbers that you are going to need, the data you're going to need, changes when you do that. Alright, so the first thing I want to know is I want to know what is the null hypothesis, and it's 13. So let's go down and put 13. Okay, and then I'm going to want to know what is the standard deviation, and the standard deviation was, I forgot, 12.9. The mean is, whoops, that was wrong. The mean is 12.9, so the standard deviation is 0.19. So it just takes a minute to change that, and it's 12.9 is your mean. And there were 32 pit stops. And my null hypothesis, I'm going to do this one because that's the hypothesis I want to see if I want to reject. And I'm going to calculate. And so that tells me that my answer, and I have that down here so you can see it, my z answer is going to be negative 2.94, and my p is going to be 0.014. So let's go back and look at that. There's my z-score, negative 2.98, and there's my p, 0.0014. And so what you do now is you go back and you compare the 0.0014, and it's less than alpha, which was 0.01, so you should reject the null hypothesis. There's a table in the book that tells you if the p-value is less than or equal to alpha, then you reject the null hypothesis. Otherwise, you state that you failed to reject the null hypothesis.